Everyone, welcome back to another exciting lesson in Math 2. This is our first lesson in Unit 7, and Unit 7 is a little bit different. Unit 7 is going to be focusing on geometric principles. Okay, it's our main unit when we're talking about geometry. Later in the unit, we're going to talk about something called trigonometry. It's an introduction to this whole world of mathematics called trigonometry. We're just going to scratch the surface this year with that. But before we get into that, we actually have to talk about something called the Pythagorean Theorem and the Triangle Sum Theorem. Both of these concepts are things that you should have learned sometime in middle school and maybe even late elementary school, but we're going to add a little bit more to it, and we're going to make sure that you understand it before we go to the next thing. I actually like the Pythagorean Theorem. I think it's one of the most popular theorems in all of mathematics, but it's definitely one of the most applicable theorems in mathematics. In other words, it is probably used more than anything else in real life, other than basic addition or subtraction. You deal with it in construction or any kind of geometric concept. So with that said, let's go ahead and get started. Our goal today is to be able to figure out the missing side length of a right triangle. Well, before we do that, we have to define what a right triangle is. So here's an example of a right triangle. We have a triangle, obviously with three sides to it, right? That's what a triangle is. And one of the angles here is a right angle. In other words, it's a 90-degree angle. It is perfectly perpendicular, okay? And that's what most angles are that we design when we're building something or when we're constructing something. So a right triangle is actually very important when it comes to construction, okay? So we need to define a few things. Number one, that's your right angle. Number two, we have two legs here. Well, what is a leg? A leg are the two side lengths that are the shortest, right? Or another way to say that, the two legs are the two that intersect each other at the right angle. So you can see that we have this side and this side. These two sides intersect each other up here. So both of these are not the legs. The two legs are the two that intersect the right angle. So this is a leg and this is a leg because they intersect each other at a right angle, okay? So those are the two legs, the two shortest sides of a right triangle. The other side is called the hypotenuse. The hypotenuse is the longest side of the right triangle. Another way of looking at that is that the hypotenuse is always opposite to or across from the right angle here. In other words, if you drew the little box that represents the right angle, it kind of makes an arrow, and that arrow is pointing to the hypotenuse. The hypotenuse is the longest side, and the two legs are the two shortest side. I just named this leg one and leg two, like thing one and thing two, right? Okay, the Pythagorean theorem says this, okay? If you have a right triangle, then we know that this equation is true, that leg 1 squared plus leg 2 squared will always equal the hypotenuse squared. Leg 1 squared plus leg 2 squared always equals hypotenuse squared. Now, somewhere in the past, you've probably been introduced to this idea of a squared plus b squared equals c squared. That's the Pythagorean theorem. Now, I have a little bit of a problem with representing it with a, b, and c, because we have lots of things in our mathematical world that we call a, b, and c. Specifically, when we're talking about quadratics, we've got a, b, and c there. But more than that, we get confused on which value is the a, the b, and the c. So that's why I have in the parentheses here that the c has to be the hypotenuse and the a and the b have to be the legs, okay? So instead of having to translate that in this sentence here, I just like writing leg squared plus leg squared equals hypotenuse squared. And if we can identify the legs, identify the hypotenuse, we have this figured out, okay? So let's go ahead and do a practice problem dealing with the Pythagorean theorem. So here we've got a right triangle. We know it's a right triangle because of the right angle right here on angle, come on now, on angle S. And we have to figure out the missing side. The missing side in this case is RS. So we have to figure out this side. So let's go ahead and do that. So here we're gonna draw the right triangle here. And my right triangle might look a little bit different than the one that's presented. And in fact, it is. It's pretty ugly, but that's okay. Here we've got 11, and here we have 7. And we're looking for this side. So something that we don't know, we'll call x, right? So we have 11, 7, and x. And our job is to figure out what that x is. Now, what we have to do first is identify our two legs and our hypotenuse. Remember, the hypotenuse is always the longest side. It's always the side that is opposite to the right angle. So this is my hypotenuse. Okay. And then the two legs are the two, obviously the other two. So this is my leg and this is my leg. Okay. They are the two shortest sides. They're the two that intersect the right angle here. So remember, the Pythagorean theorem said leg squared plus leg squared equals hypotenuse squared. Okay, leg squared plus leg squared equals hypotenuse squared. So we just plug these things in. Well, what's one of the legs? One of the legs is x. Another leg is 7. And then the hypotenuse is 11. So here we have x squared plus 7 squared equals 11 squared. You could have also said 7 squared plus x squared equals 11 squared. It would produce the same thing. So now we're just going to solve for x. We have x squared plus 7 squared is 49. And then 11 squared is 121. So you can see that this is actually a quadratic here. We have to solve for x. The best method here is going to be the square root method because we only have x squared. We only have the a. So our next step is going to be to isolate the x squared. So we'll subtract the 49. And so we end up with x squared equals 72. 110, 121. That is correct. And then from here, we're going to square root. And so remember, when we square root, oops, I'm running out of room here. When we square root, we get plus or minus, right? We don't want to forget that plus or minus, but I'm going to talk about that in just a second. Okay, so plus or minus. And then we're going to go ahead and simplify this radical. So we got to find the factors. That's going to be 2 times 2 times 2 times 3 times 3, I believe. 2, 4, 8, 24, and 72. So we're good there. Remember, we circle our pairs. We have a pair of 2s and a pair of 3s. So one of those goes out. One of each of those goes out. So we got 2 times 3. And then what's left inside is that 2. We have plus or minus here. So our final answer is going to be plus or minus 6 radical 2. But because we're talking about geometry, remember, geometry, we're talking about the length here. How far is it from R to S is really the question here, okay? Because we're talking about a length cannot be negative. Well, how many steps did you take? I took -5 steps. That doesn't make any sense. I took 5 steps. Now, you might say I took 5 steps in the negative direction, but length is never negative. So in this context, in this case, we can get rid of the negative answer. And so we're left with x equals 6 radical 2. So the missing side length is 6 radical 2. There's no context here. So we don't know if it's inches, feet, centimeters, whatever it is. So we'll just say 6 radical 2. If we are going to convert this to decimals so we can get more of a real life application, the square root of 72, if I were to type that in my calculator, would actually be somewhere between 8 and 9. So I'll say 8.5 approximately. Because remember, 8 squared is 64 and 9 squared is 81. And 72 lies somewhere between 64 and 81. Okay, so we could represent it one of two ways, either simplest radical form or decimal form. And if we're going to do decimal form, it might be best to actually type it into our calculator. So we would type in the square root of 72, and we end up with 8.485 to be more exact. X is approximately 8.485. 8.5 was actually pretty close there. Okay, so that is how you do the Pythagorean theorem. That is how you find the missing side length of a right triangle. When you know 2 of the sides, how do you find the third? You do the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Okay. Now, let's talk about the Pythagorean theorem, because actually, like I said, there's a lot of interesting information about the Pythagorean theorem. Okay. How do we know that the Pythagorean theorem works? Well, the first thing is that there is evidence that ancient Egyptians and Babylonians and Chinese and Hindus knew how to use the Pythagorean theorem. So that's kind of cool. We're talking about way back in history the Pythagorean theorem was something that was useful. In fact, there's evidence that shows that the Egyptians might have used the Pythagorean theorem to set up part of their pyramids. Okay, the Pythagorean theorem is credited to a guy named Pythagoras. That's why it's the Pythagorean theorem. Okay, it's credited. In other words, people give him credit for proving it, but in fact, he wasn't necessarily the first one to prove it. But he gets credit for it anyways. Okay, and there are over 350 different proofs for the Pythagorean theorem. That's kind of cool. There's 350 ways to know that this thing is true, that it works. A guy named James Garfield, in fact, he's the 20th president of the United States, was a mathematician who wrote a formal proof for the Pythagorean theorem. So this is just kind of some interesting facts about the Pythagorean theorem. I'm going to go ahead and show you one of those proofs, or an example of one of those proofs here. So let's go ahead and take a look at that. If I have a right triangle, obviously we have leg and a hypotenuse. Leg squared plus leg squared equals hypotenuse squared. Drum roll, please, right? So that's what the Pythagorean theorem says. Leg squared plus leg squared equals hypotenuse squared. But let's go ahead and take a look at a proof of this. Kind of cool. So if I have a right triangle, there's the blue triangle here, and I call this side A, and this side B, and that side C. The Pythagorean theorem is going to say a squared plus b squared equals c squared. What I'm going to do to prove that is I am going to draw a square that has a side length of a. So that means the two sides, or the four sides of this square, are a and a. Okay? I'm going to draw another square that has side lengths of b and b, and then another square that has side lengths of c and c. So we have these three squares that are built from the side lengths of that right triangle. Well, if I did this right, let me ask you this. If all three squares, the purple square, the green square, and the red square, were all made of gold, solid gold, and I gave you a choice, I said, which one would you want? Obviously, you're going to say the red square because that's the biggest one. But I'm going to give you a different choice. I'm going to say, do you want, I'll either give you the purple square and the green square, or I'll give you just the red square. So we know the red square is bigger than the other two. But if I gave you the purple square and the green square, would you take that instead of the red square? Well, let's find out. We're going to find the area of each one of these squares. So the area of the purple square, remember the area of a square is length times width. Because it's a square, they're the same. So here I've got a times a, which is a squared. The area of the purple square is a squared. The area of the green square would be b times b, which is b squared. And the area of the red square is c times c, which is c squared. Okay, so I'm going to move these around a little bit. So I've got my red square here. I just move it off to the side there. I'm going to take my purple square and I'm going to try and fit it inside the red square. Now, obviously, the purple square fits inside the red square pretty easily. But I'm going to take that green square and I'm going to try and fit it in the rest of the space. So I've got this green square. Oh, I've got some stuff that, is left over. I'm going to cut that and I'm going to move it over to something else. Okay, I'm going to fill that spot and then I'm going to cut it there and I'm going to take the leftover stuff, and you can see that the purple region and the green region, when you put them together, is exactly the same size as the red region. So, well, the purple region was the area of the purple square. So you can see that the area of the purple square plus the area of the green square actually equals the area of the red square. So that's kind of cool here. Now, remember, get this out of the way. It's kind of just in the way. The area of the purple square was a squared. The area of the green square, whoops, come on now. Okay, the area of the green square is b squared, and the area of the red square is c squared. So we have just proven the Pythagorean theorem. A squared plus b squared equals c squared. That's kind of cool. Okay, so let's go ahead and get back into our notes here, get some practice problems for you going. Okay. All right, so here's some practice problems that I'd like you to do. Two right triangles, I want you to find the missing sides of each of those triangles. Go ahead and pause the video and see what you come up with, and then push play to see if you are right. For number one, notice here on number one, what were the two side lengths that I gave you? What were the two side lengths that I gave you? I gave you this side, and I gave you this side. And I'm asking for this side, so I'm going to call this x. Okay. Now, those little two dashes just means inches. It's a unit of measure. This is 3 inches long, 9 inches long, and x inches long. Now, the first thing we have to do is identify our two legs and our hypotenuse. Obviously, the longest side is our hypotenuse, so this is our hypotenuse, which makes these two our legs. Okay, that's a leg and that's a leg. And so remember, the Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. Okay, so in this case, we get 3 squared plus 9 squared equals x squared. Now you can see that the x squared is already by itself, so this particular problem is a little bit easier than the one I gave you earlier. 3 squared is 9, 9 squared is 81, and then obviously x squared. We can combine those. 9 plus 81 is 90, and then equals x squared. And then we're going to go ahead and square root both sides to get rid of that squared. And so we end up with x equals the square root of 90. We know we don't need the negative version of this because we're talking about length. So we'll go ahead and do our prime factors. That's going to be 2 times 45, 3 times 15, 3 times 5. I think that's right. And then we're going to go ahead and circle our pairs. And remember, one of those goes out. So we got 3 and then radical 10. So we'd say our answer is 3 radical 10 inches. Okay, that is the missing side length. If we want it in decimal form, we're going to go ahead and just take the square root of 90. So using our calculator, the square root of 90 is going to be 9.487 inches. Okay, so depending on which way I want you to write it, simplest radical form or decimal form. Okay, and we're going to actually use both here in this unit. Okay, all right, for number two, we have a right triangle again. And this time I gave you 16 feet there and 14 feet there. And we're looking for this side. I'll call it y just for the fun of it. Well, remember, we got to identify our hypotenuse. In this case, the longest side is the 16. That's my hypotenuse. That is a leg. And then this is a leg. Okay. So again, plugging it in, leg squared would be y squared plus the other leg squared, which is 14 squared, and then that would be equal to 16 squared. And then from here, we just simplify. So y squared is y squared, 14 squared is 196, and 16 squared is 256. And then from here, we'll go ahead and solve for y. So I'll subtract the 196 on both sides, and we end up with y squared equals, I believe it's, oops, wrong button, I believe it's 60. Yeah, 60, y squared equals 60. And then we'll go ahead and square root both sides and simplify that radical. So 60 breaks down to 2 times 30, 2 times 15, 3 times 5. Okay, circle our pairs. And we end up with y equals 2 radical 15. So our final answer here would be 2 radical 15 feet, because the 1 dash means feet here, okay? If I want the decimal version of this, we would type in the square root of 60, which is 7.746 feet. So decimal form, radical form. All right, that's how you do the Pythagorean theorem. It's really that simple. You just got to make sure that you identify the legs and the hypotenuse and plug things into where they go, okay? Now, we are going to move on to something else called the Triangle Sum Theorem. The Triangle Sum Theorem. What is a Triangle Sum Theorem? The Triangle Sum Theorem says that the sum of the angles in a triangle will always add up to 180 degrees. 180 degrees. The 3 angles in a triangle will always add up to 180 degrees. So I'm going to go ahead and share with you this triangle that I have here. And we're going to find that these angles actually do add up to 180 degrees. So notice the angles. We're not talking about the side length here. We're talking about the angle measurements. In other words, how big is this angle is determined by how wide it opens up, not how long a line is, but how wide an angle is. Okay, so you have heard acute angles, obtuse angles, right angles, things like that. That's how wide an angle opens up. Okay, so these three angles should add up to 180. Well, how do I show that? Here I've got a triangle, and you can notice that I cut it up so we can manipulate this a little bit, but I got the three angles. So I should be able to say that the measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3 equals 180 degrees. Well, how could I show that? Well, if I put them next to each other, so I'm going to separate them and I'm going to move them around. So I'm going to take this angle 1 and I'm going to rotate it around like this. I'm going to take this angle 2 and I'm going to rotate it like this. And I'm going to take this angle 3 and I'm going to rotate it like that. And I'm going to put them all next to each other, adjacent to each other. And what do we see? Well, we see that these two sides make up a straight line. And if you remember, when you're talking about angles, you have acute angles. That's an acute angle. It's less than 90. You have right angles because those are exactly 90. You have obtuse angles, which means that you're bigger than 90. But then you also have this thing called a straight angle. A straight angle is an angle that is 180 degrees. So we can see the three angles in our triangle. When I manipulate them, move them around, I get a straight angle here, 180 degrees. So angle 1 plus angle 3 plus angle 2 gives you 180 degrees. And so putting them all back together, you can see that when I put the angle 1 and angle 2 and angle 3 back where they belong in the triangle, there they are. The three angles add up to 180 degrees. Okay, so let's go ahead and take a look at an example of this. Here's my triangle. My triangle says I've got two angle measurements, 47 and 53, and my goal is to figure out this other angle. Well, it doesn't really matter where I plug these angles into. I could call angle 1 47 degrees. I could call angle 2, the missing one, we'll call that x degrees, and angle 3 we'll say is 53 degrees. And those should all add up to 180. So our job is to figure out what x is, so that those three things will add up to 180. We don't need to have the degree symbols there to do the math. So we'll just say 47 plus 53 plus x equals 180. When I add that all together, I end up with 100. 147 plus 53 is 100, plus x equals 180. And so from here, you guys should already know what x is. But I'm going to subtract 100, and I end up with x equals 80 degrees. So my answer for my example is 80 degrees because those three angles add up to 180. Okay. Here's a couple practice problems that I'd like you to do before we are done with this video. Okay, so go ahead and find the missing angle of each of those triangles for me, and then we'll talk about it. All right, for number 3, the three angles are 58 degrees, 90 degrees, and the missing angle. I'll just call it y. Combining like terms, we get 148 plus y, or plus x, whatever you called it, equals 180. We'll subtract the 148 from both sides. And so we end up with y equals 32. So that missing angle is 32 degrees. Okay? And that was for number 3. Okay? For number 4, we've got 21. We've got the missing angle x, and then we've got 71. Those all add up to 180. Because addition's commutative, you don't have to, it doesn't matter which order you put them in. 21 plus 71 is 92, and then plus x equals 180. We're going to go ahead and subtract the 92 from both sides, and we end up with x equals 88. So 88 degrees is our final answer for number 4, the missing angle there. The thing I really want to emphasize, though, is the difference between an angle and a side. A side length is how far it is from one point to another. So this from this point to this point is a side length. We would do, well, let's look at a right triangle here. We would do the Pythagorean theorem to find the missing length. So how far it is from one point to another, we do the Pythagorean theorem. But if I want to know the measurement of an angle, that's how wide an angle opens up, then we would do the triangle sum theorem. The three inside values, the three angles, add up to 180. So those are the two main things we learned today. Pythagorean theorem, side length, leg squared, plus leg squared equals hypotenuse squared. And then the triangle sum theorem, the three angles inside of a triangle add up to 180 degrees. Okay. So if you have any questions, please comment below or come to tutoring and I'll be glad to help you out. Otherwise, have a great day.